Hello everyone, welcome to my YouTube channel. Today I am going to discuss about wireless network technologies. First we look at what is a network. A network is a collection of computers, servers, mainframes, network devices, peripherals or other devices connected to one another to allow the sharing of data. An excellent example of a network is the internet, which connects millions of people all over the world. In a wireless network, the same thing happens without wires. Here the data transmission happening through radio signals. There are a number of communication technologies used to communicate over wireless networks. A major difference is the use of two frequency bands which used to transfer data. The 2.4 GHz band offers better range. It handles obstacles better than 5 GHz. However, 5 GHz offers much faster throughput for maximum performance. Instead of us remembering this exact frequency on the two bands when configuring an access point, the IEEE has introduced different channels to make the task easier. So they group the different frequencies into channels. Different 802.11 standards use different bandwidths, which basically controls how broad the signal is for transferring data. Think of it like a highway. The wider the road, the more traffic can pass through. On the other hand, the more cars you have on the road, the more congested the traffic becomes. The 802.11 original standard speeds up to 1 to 2 Mbps. The 802.11 Wi-Fi standards specify a bandwidth of 22 MHz and channels are on a 5 MHz incremental step. That makes that adjacent channels overlap and signals on adjacent channels will interfere with each other. 22 MHz channel bandwidth holds for all standards. Even though 802.11b standard can run at a variety of speeds 1, 2, 5.5 or 11 Mbps, and the newer 802.11g standard can run at speeds up to 54 Mbps. The differences occur in the radio frequency modulation scheme used, but the channels are identical across all the applicable 802.11 standards. In 802.11n has two options to use. With the use of 802.11n, there is a possibility of using signal bandwidth of either 20 MHz or 40 MHz. When 40 MHz bandwidth is used to gain the higher data throughput. To avoid some of those bandwidth shortcomings with 2.4 GHz, the 802.11 AC standard uses 5 GHz. It will use a minimum of 40 MHz of bandwidth and also can double the bandwidth to 80 MHz channel bandwidth. Furthermore, it can increase the channel bandwidth amount to 160 MHz, so you will be able to send that much of data in 802.11 AC standard. Wireless devices communicate each other through an access point. The AP receives frames from the sender and transmits to recipient device. AP manages the wireless network and advertises its existence by broadcasting service set identifier, which is called SSID. Then the devices send in the association request will get connected to the AP. So all the devices that connected to the same AP will get the same SSID. There are two types of service sets. A basic set is a set of devices that connected to single AP which also connected to a wired LAN. When the network consists of more than one AP, that's an extended service set. So that an ESS covers a large area compared to a BSS. There are two MAC sublayers. The first one is distributed coordination function, which is called DCF. For the access method, they are using CSMA-CA and it offers only asynchronous service. The second one is point coordination function, which is called PCF. That is implemented on top of DCF. and it offers both asynchronous and time-bounded service. Here in the MacLayer frame, it has 9 fields. The first one is a frame control. It consists of protocol version, type, subtype, to DS, from DS, more frag, retry, power management, more data, WEP, order fields. There the protocol version and type fields has 2 bits allocated. For the subtype 4 bits, and each of the other sections has 1 bit. And the duration contains the period of time medium is occupied. After that there are 4 address fields. Those contains IEEE 802 standard MAC addresses. In the sequence control, it has 16 bits long, contains 12 bits sequence number and 4 bits fragment number, and the data field contains transferring frames. Let's see what hidden station problem is. Let's take this arrangement. Here the transition range of A reaches B but not C. At the same time, C can see B but not A, and B can reach both A and C. In this hidden station problem, when node A sends a packet to B and C is not aware of that, this because it's out of transmission range of A. Now C also sends a packet to B, sensing the node is free. Likewise, both nodes A and C sends data to node B at the same time, which leads collision. So both packets will be lost, and hidden nodes increases the probability of data collision at receiver end. The hidden station problem can be resolved by increasing channel sensing range than the receiving range, and also using multiple access with collision avoidance. That problem can be solved. In this expose station problem, assume C wants to send some data to D, which is not in the diagram. When C sends the availability of D, it finds that D is not free, interferencing B signal. C thinks D is sending data to B, but what actually happens is B receives A's data. This leads underutilization of bandwidth. Let's see 802.11 physical layer features. 802.11 FHSS uses frequency hopping spread spectrum, operates in 2.4 GHz band. Modulation can be 2-level FSK or 4-level FSK. 802.11 DSSS uses direct sequence spread spectrum, operates in 2.4 GHz band. Modulation technique is PSK at 1 mbaud per second. 802.11 infrared. Infrared light is in the range of 800 to 950 nanometers. Modulation technique is used as pulse position modulation. 802.LLA OFDM uses orthogonal frequency division multiplexing for signal generation. Operation in 5 GHz band. 802.LLB DSSS is high rate direct sequence spread spectrum, HRDSSS method used for signal generation. Operates in 2.4 GHz band. HRDSSS is similar to DSSS except for the encoding method. In Bluetooth architecture, there are two types of networks. First one is Piconet. It can have 8 stations simultaneously. There should be one primary device and others connected are called secondaries. There can be more than 8 devices connected, but there should be 8 active devices at a time. Others must be in parked state. Here you can see parks node. The nodes which are in parked states are in blue color. The light green colors are connected to each other. And the second one is scatternet. Combining piconets creates scatternet. Here secondary station of one piconet acts as a primary on the other piconet. Here in this example you can see the dark greener one is the primary of the other scatternet, other piconet, and it also a member of the another. In Bluetooth layers, we'll talk about radio layer. It's similar to the physical layer of the internet model in a way. It uses to 2.4 GHz band, and it's divided into 79 channels of 1 MHz each. It uses FHSS, frequency hopping spread spectrum, in physical layer that avoids the interference from other devices. And also Bluetooth use FSK to transform bits to signal. In the baseband layer that acts as a similar to MAC layer of the internet model in a way. The access method it uses is the TDMA. In Bluetooth frame format, there are three main sections: access code, header, data. In the header section, we can see several sections. Address section has 3-bit access subfields. There can be 7 secondaries. In type section, it's a 4-bit type subfield. Defines the types of the data coming. F is 1-bit field, it's for flow control. A is 1-bit field, it's for acknowledgement, and S is also a 1-bit field, it's for sequence number. HEC is a 8-bit header error correction data. The RFID component consists of two parts as transmitter and a receiver. The microchip stores information and the antenna is used to collect and transmit information. To read data, two-way radio transmitter or receiver emits a signal to the tag using an antenna. Then the tag transmits data to the receiver. There are two types of RFID tags: active RFID tags. They are the power needs to transmit data taken by a battery. In the passive RFID tags, the interrogator's radio wave energy used to transmit data. There are several RFID features like ability to read and write data without contact, and stored data can be retrieved without a direct contact with the device. Highly reliable system configuration become easy, and reading and writing happens using electric and electromagnetic wave transmission. Simultaneously access multiple tags like that. There are several applications on RFID, like applications tracking the assets, manage inventory, and on ID cards. There are applications on Bluetooth. It operates in 2.4 GHz band. and its duration works around 10 to 100 meters, uh, and close proximity and accuracy is not required. It works both point to point and point to multi-point wireless communications. There are several applications on of Bluetooth. Uh, we can use it for networking among several devices, uh, and using Bluetooth, the devices connects wirelessly, and data transfer such as images, videos can be done instantly. uh, we can deliver messages automatically. There are several Zigbee features. It can be used to avoid collisions and it retries acknowledgements. DSSS that provides excellent performance and it's cost effective. And yeah, Zigbee applications are using in industrial automation, home automation, smart metering, and smart grid monitoring. Hotspot has several features like uh, sharing internet connection or restrict devices, sharing secure and safe way, and it applies on Wi-Fi map, Wi-Fi finder, and Wi-Fi VI-man. And there's another emerging technology called Li-Fi. Li-Fi is invented by a German scientist named Harald Haas. It transmits data via light. It has some features. In the spectrum, it provides 1,000 times more unlicensed spectrum than traditional wireless communication. Uh, and it offers 10 times faster internet than traditional Wi-Fi speed. The light can't go through physical items, so it provides more secure connection, and also it's environment friendly. For the Li-Fi applications, we can use Li-Fi in traffic management and road safety, medical applications, aviation, communication underwater, elegant lighting, and also additionally we can use it on a interior map reading system for blind people, or in dangerous environments, or in sensitive regions, transportations, industrial areas. A wireless sensor network consists of hundreds of sensor nodes. We can use it to monitor physical environment conditions. The sensor nodes communicate with each other using radio signals. After nodes are deployed, they are responsible of self-organizing an appropriate network infrastructure. Actuators also can be integrated with WSNS. There are three topologies. Uh, the star topology, each node connect directly to a gateway. Nodes are not allowed to send messages to each other. The remote node power consumption is minimum. The tree topology, it is called cascaded star topology. Each node is connected to a higher node in the tree structure. Network expansion can be easily done. In mesh topology, nodes connect directly, dynamically with the other nodes in the network. Provides easy isolation of the nodes. Network becomes large. There are certain WSN characteristics. Uh, it has scalability to large scale of distribution, and some mobility of nodes and heterogeneity of nodes. The consumption of power limits for nodes with batteries. It's simple to use. It has a capability of handling node failures. uh, it can be designed cross layer. Okay, it has the capability to ensure strict environment conditions, and there are several advantages of WSN. It is flexible, uh, and also it's inexpensive. The network arrangements can be carried out without immobile infrastructure, and it can be used in unreachable places like mountains, over the sea, rural areas, and deep forests. And there are several applications of WSN. We can use it for sensing events, healthcare monitoring, environment monitoring, home security, landslide detection. We can design our own wireless network using two ways. First one is manual design. We can identify the strength of the signal by moving AP into different locations. By moving it, it is necessary to check signal strength, signal to noise ratio, radio frequency interference, and surrounding wireless networks. This is a very accurate method, but it very time consuming. And the second and the latest one is to use a tool. For that we need a software specially designed for this, and we have to upload the site plan to the software. Then we can define the wall types on the map, and the AP locations virtually. After that, network planning is done by site planning tools. Wi-Fi supports two different frequency bands. Each band is divided into channels. There is a total of 14 channels defined for use by Wi-Fi 802.11 for the 2.4 GHz ISM band. Not all the channels are allowed in all countries. 11 are allowed by the FCC and used in what is often termed the North American domain, and 13 are allowed in Europe, where channels have been defined by ETSI. The Wi-Fi channels are spaced 5 MHz apart, with the exception of the 12 MHz spacing between the last two channels. As the 2.4 GHz band becomes more crowded, many users are opting to use the 5 MHz ISM band. This not only provides more spectrum, but it is not as widely used by Wi-Fi, as well as many other applications using items such as microwave oven, etc. For we can see the non-interference channels available with width of the channel. If the channel width is 20 megahertz, we can see some certain amount of interference channels. If the channel bandwidth is 40 megahertz, the number of non-interference channels are getting lower. You can see if the channel bandwidth is 80 megahertz, there is only 4 non-interference channels available. If we want to select non-interference channels from several zones, you have to detect some conditions like slow zones from competing networks, because we have to remove the interference from the networks coming from the surface. And there are two types of Wi-Fi interference. Uh, Co-channel interference is the first. This is called crosstalk of two APs when they are using the same channel. The overlapping interference are the networks unable to cooperate. That happens when the networks are not cooperating each other. And there's another one option we have to look into, dead spots from non-Wi-Fi devices. Sometimes you may not have good connection, which can happen due to the devices that use same frequencies as Wi-Fi, like cordless phones, microwave oven, wireless audio systems likewise. To set up a wireless router, we have to purchase a router first, then connect the router to the modem, and then connect any devices you want to hardwire with Cat5 Ethernet cables. Then you connect the computer via Ethernet. A Wi-Fi controller is a centralized device which manages all the access points in a location. There are several functions of it. It provides centralized authentication, centralized radio management for all access points, load balancing, radio balancing, failover, radio frequency visualization, network access control based on user identity, security, and mesh connectivity. WEP security standard released in 1997. The encryption algorithm used in WEP is easily breakable by hackers. Encryption refers to the technique of converting data in such a way that is understood only by sender and receiver. In WPA, the encryption is released in 2003. It's invented by Wi-Fi Alliance, and it only requires firmware upgradation instead of changing the hardware component. The algorithm is used is TKIP, and it's known it's only better security than WEP. WEP2 is released in 2004. It has advanced security features. The encryption algorithm is Advanced Encryption Standard AES. MIMO is an antenna technology for wireless communications in which multiple antennas are used at both in the source and the destination receiver. The antennas at each end of the communication circuit are combined to minimize errors and optimize data speed. MIMO is one of several forms of smart antenna technology, the others being MISO and SIMO. Thank you for watching.